Welcome back. Recording the notes. We have notes on special cases. We're just going to jump right into question 1. We're just going to see what happens. Before we get to question 1, I guess I kind of lied a little bit, because before we get there, we're going to play a quick game. It's a super fun game. What up? All right, sounds good. Great start. There you go. All you. So, we're going to play a quick game. The game is the game of true or false. And what you're going to do is decide, is it true or is it false in a math sense. Thank you for facing forward. We've got 4 equals 5. What do you think? True or false?
False.
What do you think? 4 equals 5. Is that true?
No.
Of course not. 4 equals 5 is false. I think that a first grader could tell you that 4 equals 5 is false. What about this one? What about 3 equals -7? True or false?
False.
Why is it false?
Well, wait, we actually got to think about and explain that, because 3 is comprised of 3 different numbers.
Because they're not the same. How about that? Because they're different numbers, right? Don't overthink it. So how about this one? Okay. What about 6 equals 6? Is that true or false?
True.
That's true, right? Does not get any easier than this. I think that a first grader could figure this out. Here's one that for some reason people were actually confused by earlier today. What do you think about 5 equals -5? Is that
False.
true or false?
False.
Are these the exact same numbers?
No.
If this was the score, 5 to -5, is it a tie game?
No.
No. This is a false statement. So, now, as easy as this is the reality of what you need to be able to do today. You need to be able to look at 2 numbers and decide, are they the same exact number or are they different numbers? Please do not talk over me. We're getting started on the notes. Be quiet. So for number 1, we've got a little bit of distributing going on. We can handle that. That doesn't scare me, okay? When we distribute, we're going to have 4 times -7 is -28. When we distribute, what's the second term going to be? That's right, positive 16x. On the other side, nice, 16x. Be careful on this one. -32. And then don't forget that little plus 4. Now, so far, we've handled everything. I want to pause for just a second. When we're solving this question, what is our end goal? What is the mission of this question? What are we trying to do? Nice. We are trying to find x. We are trying to solve for x. Perfect. That is our mission for this question. All right, let's get back to it. Now, a little bit unusual today, you're going to have to be combining like terms a lot, okay? Look on this right side. You see how we have 3 pieces? 16x, -32, positive 4. 2 of those are going to combine together. Which 2 combine?
-32 and 4.
Of course, of course. And when you combine them, all you do is smash them together, right? Just type in -32 plus 4, right? Simple math. What is -32 plus 4? -28. So be careful, right? That's why we did this one. That's why I was waiting on you guys. And so, when we get this far, hopefully you have a math sense or a math brain or some kind of math heart that is looking at this question and is thinking, ew, something weird is happening, right? Kind of gross.
Oh, wow.
So, if we keep finishing this question, let's move the letters left. -16x, -16x. What is 16 minus 16?
0.
0. And on the other side, what is 16 minus 16? 0. So what the heck just happened to us?
Oh, we got no
Now we
x.
gotta bring this down.
So you're both correct. All the x's are gone. Has everybody seen that?
Yep.
The x is on the right, deleted. The x is on the left, deleted. All of the x's have been obliterated. They're all gone forever. Okay? No más x. Okay? No more x's. So, here's what we got. We're going to bring down what we have left, which is negative 28. And what's on the right side? Negative 28. Now, don't go any further. We want to stop right here. We want to stop because there's no more x's. And what is our mission? To find the x. Can we find the x anymore?
No.
No. There is no way to find the x because the x's are literally gone. Okay? Now, I always end up sharing this with class. Back when I was in high school, used to play a lot of video games. Used to play a lot of Call of Duty. All right?
X equals 0?
Oh, sorry, it's quiet on my computer. Here we go. You guys ever heard this before?
Mission failed.
We'll get it next time.
Yeah, you guys ever heard of that? I don't know if it's dumb or not. When I was a kid, I used to play a lot of Call of Duty, and every time you lost, you'd hear this guy, and he'd straight up say,
Mission failed.
and so when I solve these questions and all the x's disappear, I think mission failed, right? Dang. Rip, right? Super sad. Now, we still need to come up with an answer. But our answers are going to be a little different, okay? It's not going to be x equals 5, x equals 6, because there's no more x's. We have two options.
True.
They're going to come from true or false, but it's not, the real answer is not the word true or false, okay? First of all, look at this. Negative 28 equals negative 28. Is that a true statement or a false statement?
A true one.
That's a true statement. If the answer is true, look up here on the top. If the remaining statement is true, then it is all real numbers. Okay? We get a little 3-word finish. Basically what that means is every single x number works. No matter what x you pick, it will work. If you pick 1, it'll work. If you pick 2, it'll work. If you pick negative 32 divided by 7, it will work. Every single x number ever will work. But you can't just pick a random one. You have to say all of them work. Luckily, we're going to use an abbreviation in class. We're just going to say ARN. Okay? So, as weird as that probably was for the very first question, here's what's going on. We're solving the question. Easy, we're chilling. All of a sudden, all the x's are gone. Stop. Are you looking at a true or false answer? If it's true, you just put ARN. You're done. Okay? Let's see the second question. You know, I got an idea that this one might be false. You know what I'm saying? We might see both of them right here. So, I'm going to do some distributing again. It does make sense that you should plug in your own charger. Yeah, thank you. So, now that we have distributed, let's make sure we get what we got. Negative x, distribute the negative 4 using multiplication. Positive 12. What's negative 4 times negative x? Positive 4x. And you guys help me out with the right side. I've done a lot of work so far.
3 times. There you go. So it's 3x.
Yep, 3x.
Then minus 15.
Minus 15. All right, cool. Like I said, a little bit weird today. You're going to have to do some combining like terms. So if we look to combine these together, I know this is negative 1x.
11. No. Oh, never mind. That's wrong.
These two need to combine.
4.
Negative 1x's plus 4x's. Right, it's just 3x, easy peasy. 3x plus 12 equals 3x minus 15. Again, hopefully in your heart you can see this and you're thinking, kind of gross. Something weird is happening here.
Which color?
What?
Does NS equal no solution?
Clever. We're going to have minus 3x minus 3x.
So it's just 12 equals negative 15.
We're going to have 3 minus 3, which is 0. 3 minus 3, which is 0. And what happened to all of our x's?
They're gone.
Mission failed.
They're gone. All right, the question is ruined. We have no more x's. We cannot continue. Okay? There is no possible way for us to find out x equals whatever, because the x's are gone. All we have left is a simple statement. 12 equals negative 15. On any planet in this galaxy, does 12 equal negative 15?
Absolutely.
No, they're not even close. Okay? So, this is a false statement. And let's look up at the top. When the remaining statement is false, we had some really clever context clues, right? ARN/NS. And so, yes, NS, no solution. All right? What that means is that no matter what number you pick, you could try every single number between negative 10 billion and positive 100 trillion. Still, none of the x's would work. This would be false every single time. So, we're going to put in S. All right. Honestly, it's a pretty simple day. You solve the question, and all of a sudden, the x's go away. Once you're solving the question and the x's go away, stop the question, look at what you have left. Is it true? You put ARN. Is it false? You put NS. That's it. Okay? What we're going to do on number 3 is I'm going to do the first step, and then you are going to try to finish it. So, for number 3, we're going to do distributing, distribute, distribute, distribute. I know we don't have a lot of room, but the truth is these are kind of short questions. They're really not that bad. Okay? The first step is going to be 5 plus 3 times x. 3x. 3 times negative 2. Negative 6. Equals. On the other side, 5 times 2x. 10x. 5 times 2. 10. And this negative 7 is not getting distributed. It's just going to stay negative 7x. Okay, I've got you started with the first step. What you need to do is combine like terms, see what you can get going, and I'll give you a hint. The x's should probably disappear in about 2 steps. Okay, try it out for yourself. I'll give you guys, here we go, we'll hit a little timer on it. Give us a minute of practice on our own. 1 minute. You got it? Love it. Nice job. Perfect answer so far. Perfect. 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 Nice. We're doing very well. I don't think it's super tough. Nice. Awesome. Perfect. We're going to combine some like terms. So look on the left. 5, 2, exactly. So 2, combine them. Combine it on the right. Let's look on the left. Let's look on the right. There's that x and that x. Those can combine. You got it? Nice. Looks good. What are we doing? Well, stuff on the paper there is looking good so far. Perfect. Nice start. Looking very good so far. Finish it up in 10 seconds. You'll be straight. All right, that was 1 minute and 2 seconds. So, I'm just going to keep it going. I know it's just notes, so it's okay if you kind of got stumped a little bit. Don't stress. What can we combine on the left? The 5 and the 6. But it's a negative 6. So you should have negative 1 plus 3x. On the right side, we also can combine these terms. 10x's and negative 7x's. 10 minus 7, that's easy. That's 3. And now, what's going to happen? Hopefully in your heart of hearts you can foresee these x's. They're matching up. Minus 3x. Minus 3x. And what's 3 minus 3? 0. And what's 3 minus 3? 0. And what are we going to listen to for the 10th time today?
Mission failed.
There we go. This question has been destroyed. The mission has been failed. Negative 1 equals 10.
It's over, bro.
So, if we have negative 1 equals 10, if you go ask a second grader, hey dude, is negative 1 equal to 10? They're going to say, high school's weird. No, of course, negative 1 is not equal to 10. So, this is clearly a false statement. And is false, ARN, or is false, all real numbers?
It's NS.
Haha, good trick. False is NS for no solution. I tried to trick you guys. You got
Said
it.
both the same thing.
Exactly. I tried to get you, catch you slipping. False is NS. All right. The last question is the easiest one out of all of them. It has the least amount of steps out of all of them. This one's all up to you. Try this out. See what you get. See if you run any problems. And we'll be done.